So the welcome for DDC lab for the program number 2. Design a 4-bit full adder and subtractor and simulate by using a basic gear. For this program we can realize by using a software. With the software program with the verilog, we have to design for the 4-bit. Because of that we are taking A0, A1, A2, A3 4-bit, B0, B1, B2, B3 for the 4-bit. See, this is the diagram for that. So we have a full adder, 4 full adder we are taking. We are passing the value of A0 and B0, A1, B1, A2, B2, A3, B3, including that the initial C in will be provided with 0. And for the full adder 3 input, I am getting the sum is equal to 0. And the carry has to be propagated from the previous full adder to the next full adder, that is a C0, and the next input A1 and B1 will be adding. So this diagram you need to identify one more thing for this green color M. The M bit will be acting as either an adder or subtractor. Whenever initially that M bit will be initialized with 0, then this is acting as an adder. Then if you want to perform for the subtractor function, you need to change M is equal to 1. See, that value will be passed on to this XOR, and the XOR will be do that modification to be act as an adder or subtraction. So this is a diagram for you need to remember for writing the 4-bit adder and subtractor. Then how to write the coding part about this one? For that internally, for the full adder diagram, so this is be represented with the binary gates with respect to this is the diagram. So this diagram you need to write it. This full adder A and B with the input XOR of that, and A, B will get AND gate, the C input. So this is the sum we are getting, and you have a carry will get A, B will get. This is the full adder. So whenever I want to realize this program with a verilog, with the verilog program, I am writing the verilog program. Module is the keyword followed by the name of the program, and sum and carry is the output. A, B, C are the input. The next I am mentioning what is an output? Sum, output is carry. These are the three are the input, A, B, C input. And what are the intermediate I am representing here? The intermediate is W1, W2, W3. These are the intermediate output. It acts as both input and output that I am defined by using wire. In the verilog, it acts as a both input and output that will be acting as a wire W1, W2, W3. So next, I am writing the program in verilog structural model. The structural model, I have a gate with XOR. This is an XOR. The output name is W1. Input is A and B. XOR, I am providing a user defined name as an X1. According to that, XOR is my primitive. What is an operation I want to do? XOR operation. What is the name of the XOR? X1. What is an output? W1. See the W1 followed by A and B are the input. See, this is the component level structuring model is done. Let me go for the AND gate. AND is a primitive, and X2 is the user defined name. See, this is for I am doing the X2 is the user defined name for the AND gate. The output is W2. What is the input of this? A is an input, B is an input. According to that, AND gate, X2 is the primitive, that name of the AND gate. W2 is an output A and B. The followed by I have one more XOR operation. The name is X3, and sum is an output. W1 and C in are the input. Let me say observe. X3 is the name of the second XOR. Input of this is W1 and one more input is Cin. So what is an output? So that output we call as a sum. According to that, XOR X3 output is sum W1 and Cin. The next we have an AND gate. The one more AND gate. The name is X4. You have to take X4 about that. W3, W1, Cin. What is the W3? Output of this, and input is when providing with Cin as well as the W1. See, that has provided. At the last one, X5. The X5 is the OR operation. Input is W3 and that one is W2. Output we call as in carry. See, this is for X5 with carry, W2, W3 and end model. This complete program is called as a full adder in structural model. Separately asked in the exam, write the verilog code for the full adder using structural model. You can use it. Say, according to my lab program 2, this is called as a one sub problem. See, because whenever I am to design 4-bit binary order, I need to call this program 4 times. See, because 1, 2, 3, 4. Instead of writing 4 times, I am defining 1 time in my program. I am calling in 4 times. So let's see, go for the main program for the 4-bit binary adder carry. This is the name of the program, binary adder carry. Sum is an output, A, B and C. For this, sum I am representing with S0, S1, S2, S3. So because of representation, LSB bit is 0, MSB bit is 3 and C out only one carry out. Inputs are A0 to A3, B0 to B3. Because of that, inputs are represented B0 to B3 and C in our input. And these are the carry propagation from one full adder to the next full adder. You should be observe the diagram C0, C1, C2. It is acting as an input as well as an output. Because of that, I am representing the wire in the program C0, C1, C2. And next we have a W1, W2, W2, W4 as the name of your, we are using in the XOR output. See, that's why I am calling as in wire. So let me go the first operation I need to do for the XOR. So what is that one? N1. Let me observe this diagram of that one. You observe this. See, we have a W1, W2, W3, W4. This is an XOR. How many XNOR I want to do? 4 XNOR I want to do. The first I will do the XNOR of this. Each XNOR I should be given a name as N1, N2, N3, N4. Don't confuse. W1, W2, W3, W4, the output of XOR. I am giving a name N1, N2, N3 as the name of your XOR. See now, I have to do for this program 4 XNOR operation N1, N2, N3, N4. The output of first XNOR is W1. For that, input is Cin is common to all. That is a M bit is 0 and B0, B1, B2, B3. See, because the first XOR, the Cin is common, B0 is I am providing, the output is called as in W1. So this is one. This is the Cin is common to all that XOR. See, I will tell you that that's because of that you need to change only B0, B1, B2, B3. The Cin is common. We are doing for all XOR operation. It will give either is working as an adder or subtractor. The Cin value, whatever is sending, according to that, it will calculate. So once you're done, the next part I need to call a full adder. The full adder, how many times I want to call? 4 times I need to call. Because of that, I am writing a full adder is the calling name, followed by an optional full adder name FA0, FA1, 2, 3. You can give any name, followed by the parameter. That full adder parameter, first one is the output, second one is the carry. The full adder 3 input A0, W1, Cin. So these are the 3 input I need to provide for the full adder. Let me check for your diagram. So this is my diagram. So once you got this output, I have to realize these full adder. The one is A0, one is W1 and third one is Cin. Because of this, if FA0 I am giving name to all, I am taking the same name, full adder with these 3 parameter with the output sum, one more output C0. Let me observe the program that sum C0, A0 and W1, C2. Same way A1, W2, C0, A2, W3, C1. Finally A3, W4, C2. The output is not C3, output is C out. Every student will be made mistake here. C0, C1, C2. The last one we call as a C out. Then the C4 module will be calling and you have to call for the end module. See, this is for how to design your program for the 4-bit binary adder using that half adder as well as the full adder. Thank you.